This is James from the Element 14 community, and I'm going to walk through Lab 9 of the Path to Programmable project, and I'm going to go ahead and get started here. So what Lab 9 is doing is showing us the power of the Tickle interface, TCL, if you will, and so I'm going to start by opening my Zinc Design project, and this is the actual Vivado project file itself. So it's not a script, it's not the TCL or anything like that. It's the actual Vivado file. So this is when you're working on a project, it's actually saved into this file. So this opens up. We can see the Tickle console down here in the bottom, and it's actually showing what's going on. It's loading the file, it's starting the GUI, it's doing all of this stuff. So what I feel is actually happening is that the UI is really just a wrapper around the Tickle console. Okay, so I've got it open. I'm going to start by going into my block design, and we can see where we actually start as a baseline. And so it's going to open the board itself, and we can see we've got our Zinc processor right here, the AXI interconnect, we've got our BRAM controller, we've got the PWM interface we added in the previous lesson, and the reset controller. Of course, then our logic analyzer here, and our LED. Okay, so what we're going to do now is we're going to change directory to launch our Tickle script file, which is going to put everything else in here for us. And this is basically, it's like a command line like you might be used to. So I'm going to change directory here, C Speedway, if I do this correctly. Okay, Speedway, Zinc Hardware 2017-4, Lab 9. And you can see the smart interface on here. It's prompting me which folder I might actually want to go into. I do a pwd command, print working directory, to make sure I'm correct. And then what I'm going to do is source lab9.tcl. And this is actually going to go out and grab the file and start running it. So we see it executing, and you can already see our diagram over here on the right updating. It's starting to add blocks, and eventually it's going to add the connects between everything. It's adding all of our ports. It's going through, it's actually saving, okay, doing launch runs command. You can see the TCL command. This is the actual script itself that's running. We can take a quick peek at that. So I'll just pull this down while that's going. We're just going to look at the end here. It's, as you can see, it's almost 700 lines of code, but it finishes up. It's connecting the board nets itself. It'll regenerate the board interface. It sets memory locations, adding files and constraints. Then it will save the board, it'll run the synthesized design, and then it actually writes the bit stream out. So there's a lot going on in here, adding I/O, multiplex I/O, I2C port interfaces. So there's a lot going on in the actual file. Okay, so it's pretty much done with that portion. As we can see here, it's got a little bit more that it's doing, and you can see in the right, it's running the synthesized design. So that's actually going through, and this is the part that takes about 15 minutes to do, which is I'm not entirely sure why, but if I look on Task Manager here, it looks like what it's actually doing is only using one core at a time, and the CPU controller is bouncing it around between different cores on the computer. So it does take a while, and perhaps it could go faster. I'm not sure. I don't know exactly all that goes into it, but that's what we're doing. That's Lab 9. So I'm going to cancel the design just for this demo here, and I can show you what we've ended up with here. So here, this is the Bluetooth controller, or sorry, this is the wireless interface, the wireless manager. So that's been created, along with a Bluetooth UART, which communicates with that in between. I can make this kind of pop open like that a little bit better. There's the zinc processor. We've got our AXI interconnect right here, which is going in between. You see the master AXI GPO0 coming into the interconnect. And then the interconnect goes out to each thing, like the Bluetooth, our BRAM controller, the PWM controller that we created earlier. We've got a couple AXI I2C interfaces. Those are for the PMOD connectors, which the PMOD connectors are these down here. These pin headers on the edge of the board. And some GPIO for the LED and for a switch. So that's all been created. We also have an XL constant here, which gives a constant value. If we follow this net into our zinc, it's also created a reset controller, which can reset actually all of the things on the I2C command based on what it's been told to do, and a concatenate. So we've got interrupts coming from all of the different devices that feed into this concatenate block, and that will feed just a single interrupt back into our zinc controller. So that's what we've done from our tickle script, and it shows it's quite useful, and there's quite a bit that you can do with it. So thank you guys very much.